Take a look at this question. What is the units digit of a 3 to the power of 85? We could try to calculate it, but that would take way too long. There has to be a faster way. Here are the first few powers of 3. Wait a minute. Look at the units digit of every power. 1, 3, 9, 7, 1, 3, 9. This looks like a pattern. 1, 3, 9, 7, 1, 3, 9, 7, and so on and on. Every fourth number we repeat. Okay, but how is this going to help us solve the question? Well, every fourth exponent is going to be 7. So the 84th exponent will also be 7 because it's divisible by 4. And 85 is just one exponent later. So the units digit of 3 to the power of 85 is going to be the same as the units digit of 3 to the power of 1, which is 3. Here's another way to look at it. When you divide 85 by 4, you get the remainder 1. And the units digit of 3 to the power of 1 is 3. So the units digit of 3 to the power of 85 is also going to be 3. Turns out, every number has a pattern like this. And you can use the same method to find any units digit of any exponent. Here's a table showing the pattern for all single-digit whole numbers. As you can see, some numbers such as 0 and 5 will always end in the same digit, and some numbers, like 4 and 9, only have 2 values in the pattern. Pause the video and try to find the units digit of each of these exponents yourself. Ready? Let's start with the units digit of 7 to the power of 36. We can go to the 7th row, then calculate the column by finding the remainder of 36 divided by 4. That's going to be 0, so we can go to the column marked 0. The intersection of this row and column is 1, so 1 is going to be our answer. The next question is similar. We can go to the 4th row and the column marked 1, because 49 divided by 4 leaves a remainder of 1. The intersection gives us the 4, so that's our answer. The final question asks us to find the units digit of 6 to the power of 3,136. We could use the method we used in the previous problems, but it won't matter because 6 to the power of anything is always going to end in 6. Now that you understand how to find the units digit of basic exponents, let's look at a little more complicated problem. First, see if you can figure it out yourself. Okay. This question is definitely much more complicated than the previous ones, but there's still a way. Don't get intimidated by the exponents on exponents. You can pretty easily simplify them. Just multiply them all. 7 to the power of 8 to the power of 9 to the power of 10 can be simplified to 7 to the power of 720, because 8 times 9 times 10 is equal to 720. Similarly, 3 to the power of 4 to the power of 11 to the power of 12 can be simplified to the 3 to the power of 528. Now, we have to find the units digit of 7 to the power of 720 and 3 to the power of 528. 720 divided by 4 leaves a remainder of 0, and looking at the previous table, we know that 7 and 0 intersect at 1. 528 also leaves a remainder of 0 when divided by 4. The intersection between 0 and 3 on our table is also 1. Now that we have the units digit of both the exponents, we can add them together. I'm pretty sure that 1 plus 1 is 2. So the units digit of that big equation is 2. Now you know how to find the units digit of complicated exponent expressions. As always, if you have any questions, please post them down below. And thank you for watching.